Hey everybody, this is Mr. Mayer, and in this video we will prove triangle congruence. By the end of it, you want to be able to say, I can use a two-column proof to prove two triangles congruent by the angle-side-angle congruence postulate. So taking a look, we are going to use a two-column proof to prove the following. So we're given that line AN is parallel to EL, G is the midpoint of EN, and we need to prove that triangle NAG is congruent to triangle ELG. So, getting started. Again, always make sure you remember what comes first in your proof table. It is your givens. So this is always coming first. Your proof statement is what we are going to end with. So always keeping this in mind, we want to see what information do we have in order to prove these two triangles congruent. So taking a look, what we're going to do is, again, starting off with the givens, we see that these two lines are parallel. How did we know this? It's because it is given information. Okay, now again, what we want to do is anytime we're writing the information in the table, we want to go ahead and put it in the diagram as well. So line AN is parallel to line EL. I'm going to make that parallel symbol using the two arrows, showing that these two sides are parallel. These two lines are parallel. Now, again, we can always put the givens first, but it's best to start using the information from each step to help us create the next step. So if I know that I have parallel lines, if I know that AN is parallel to EL, the question is, what's the purpose of that? What do parallel lines create so that I have maybe some more information helpful to me? Again, the purpose of this is always to find congruent sides or angles. If I am using parallel lines, I notice parallel lines with a transversal create some congruent angles. So I'm going to go ahead and just use this transversal. You could have used this transversal if you want, but I'm going to go ahead and use that. If you recall, using angles, the angles created using these parallel lines with the transversal, I'm going to see that this angle in between the two parallel lines would have to be congruent to this angle in between the two parallel lines, because these two angles are alternate. They are on different sides of this transversal. One's above it, one's below it, and they are interior between the two parallels. These are alternate interior angles, so I know step number 2 is that angle E is going to be congruent to angle N, and the reason for that is because these are the alternate interior angles. We're using the alternate interior angles theorem to say that this angle is congruent to this angle. So far I have a pair of angles. Okay, so again, I'm trying to think of all my new theorems, my new ways to prove that triangles are congruent. We've talked about SSS, we've talked about SAS, and we're going to be talking about this new one, angle side angle, in this video. So let's go ahead. Now that I've marked that, I can actually, if you want to, you can go ahead and mark this angle using, instead of a normal facing Z, we could have used the Z backwards. I'm just going to go ahead instead and use this information, the other given. It says G is the midpoint. Again, the reason that we know this is because this is given information. Now, if G is the midpoint, where does that mean G lies in regards to this entire segment EN? G is going to land directly in the middle. So since this is exactly in the middle, that means that this is half and this side is half, meaning equal halves are going to be congruent to each other. So that means that this side is going to have to be congruent to this side. So what we've done is we've created our step number 4, and I now know that segment GE right here is going to be congruent to segment GN. Okay, so again, these two are going to be congruent. How did I know that? What did I use from number 3 to help me make number 4? What I used from number 3 was the word midpoint. I used its definition. So that is the definition of midpoint for number 4. That's how I know that those are congruent. So again, marking that off to the side, I know that this is a side. I have an angle, I have a side, and the name of this lesson, the name of this video is angle side angle. So as you can guess, we're trying to find a third piece that's congruent, which is going to be an angle. So going back to older stuff, I'm seeing that here's a vertical angle to this vertical angle. Vertical angles are going to be congruent. and that is by the vertical angle theorem. So I'm going to go ahead and mark that. Use two arcs, two curves. Curves are called arcs, so that you know that this is different from the original angle we started with. So I know this angle is the same. Again, I cannot just name it angle G is congruent to angle G because there are two angle G's for each triangle. They're different. So I want to make sure I'm using 3 letters for each of these. Make sure your 3 letters are matching up when you do this. So I'm noticing that angle AGN is congruent to angle LGE. Okay, and that is because, again, those were vertical angles to each other. I use the vertical angles. Make sure you put that word theorem because the theorem states that vertical angles are congruent. The last step, again, make sure this was an angle. Here's the question. Is your side included between the two angles? Look at the diagram. Is this side included between the two angles? Yep, it sure is. So this is angle, side angle up here. Is this side included between these two angles in the bottom one? Yes, it is. It's included. It's right in between, so that's angle, side angle as well. And therefore, I know that my triangles have to be congruent to each other because that is one of my congruence postulates. Triangle NAG is congruent to triangle ELG, and the reason for that is because it's the angle, side angle congruence postulate. All right, guys. Thank you for tuning in. See you soon.